All right, so the second part of 2.5, we start using these properties to form logical arguments, and we get into a couple more properties. So the first one we're going to talk about is the reflexive property. It essentially says that something equals itself. Okay, so if we're talking about any real numbers, any real number a, then a equals a. So for example, it'd be like 8 equals 8, or 12 equals 12. Any number equals itself. For a segment length, any segment length is equal to itself. And for an angle measure, any angle measure is equal to itself. Okay, so like when you look at yourself in the mirror, you're the same height. Okay, anything is equal to itself. The symmetric property basically says that both sides flip-flop. So, oops, can't spell. So both sides the same, and you flip-flop. So for example, for any real number a and b, if a equals b, then b equals a. For any segments, if AB equals CD, then CD equals AB. And for any angles, if the measure of angle A equals measure of angle B, then we could say the measure of angle B equals the measure of angle A. Okay, so symmetric property is when you flip-flop it. Oops. Right, and then transitive property is like saying, I know this, therefore this. So a couple examples down here. If it's a real number, if we have real numbers, if A equals B and B equals C, then we can say that A equals C. For segment lengths, if AB equals CD and CD equals EF, then AB equals EF. And then for angle measure of angle A equals measure of angle B, and measure of angle B equals measure of angle C, then the measure of angle A equals the measure of angle C. You'll notice that in each of these, something is repeated. B is repeated, CD is repeated, and angle B is repeated. Okay, so this is kind of like saying you have three people. It's like saying if I am as tall as somebody else, let's say I'm as tall as Brandon and Brandon's as tall as Ashley, then I'm as tall as Ashley because we're all the same height. That is the transitive property. Okay. Example 1, it says show that CF is equal to AD in the diagram at the right. We're going to actually skip this because this actually comes up again in the next section of proof. So we may come back to this in class, but for the video portion, I'm going to skip it. So checkpoints. Name the property of equality that is illustrated. So if GH equals JK, then JK equals GH. So here we are flip-flopping. Flip-flopping would be the symmetric property. Okay, my writing looks terrible. Let me fix that. Symmetric. And the reason why I can remember symmetric means flip is because I look at, there's two M's. So if you flip those M's, it's still the same word. So I think symmetric means flip-flop. Okay. And number 2, if R equals S and S equals 44, then R equals 44. So you see how it's comparing three things, R, S, and 44. This is the transitive property. And how I know transitive is because transitive compares three things. And then lastly, measure of angle A equals measure of angle A. This is the reflexive property. Right. Short and sweet, but those are the three properties: symmetric, transitive, reflexive, and we're going to practice that more on Monday.